Hi, students and friends. Welcome to the channel Learn and Teach by Sir Ayaz. I will continue my lesson for alkenes, but this time we'll talk about isomers and isomerism. The learning outcomes for this lesson would be define isomerism and identify isomers. Draw the structures of branched and unbranched alkenes C1 to C4 and name the unbranched alkenes ethene to butene. We have to recall few things before proceeding. Carbon belongs to group 4 of the periodic table, which means each atom of carbon is tetravalent. Tetravalent means an atom has valency of 4. A carbon atom in either hydrocarbons or organic compounds form only 4 covalent bonds. It will neither form 3 bonds nor 5 bonds with other atoms, which means both of these are incorrect. This is the right way of drawing. Note one thing here, that there must be carbon-carbon double bond in alkenes. So there must be one double bond between 2 carbon atoms, not only one bond. So these 2 bonds will be counted as 2 bond, not 1 bond. When 2 or more compounds have same molecular formula but different structure formula, they are called isomers of each other. The phenomena is known as isomerism. Isomers can be made from straight chain by removing and placing the end group in the middle of the chain. Now let's draw the displaced formula of alkenes for the value of N2 and N3. If value of N is 2, then the molecular formula will be C2H4. The name is ethene. If the value of N is 3, the molecular formula would be C3H6. Name is propene. Let's draw there. It's propene. Their displaced formula for ethene, it will be like this. Isomer is not possible here. You can't have different structure for this ethene. Let's check propene. 1, 2, 3. You can place double bond between any 2 carbon atoms. For example, I'm placing between these 2. Now I will satisfy the valency of carbon. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You can also draw this member like this, meaning that the double bond will be changed from right side to left side. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Both of these are same. Which means that isomers are not possible for these 2. Isomers are not possible. What about the next member, which is butene? The value of N is 4. The molecular formula would be C4H8. Let me draw the display formula for this one. There are 4 carbon atoms. So 1, 2, 3, 4. Now I will place carbon-carbon double bond between any 2 carbon atoms. I can place the double bond. I'm placing it in the middle. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If you want, you can count the number of carbon atom and hydrogen atoms. You will get C4H8. Now I want to draw the isomer of this. You see, carbon-carbon double bond is in the middle. If you will start counting from right side or left side, it will be like this: 1, 2, 3, 4. Name will be 2-butene. Now you can draw the isomer for this one. What I will do, I will simply change the position of carbon-carbon double bond. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now place the hydrogen atoms. You see, I have changed the position of carbon-carbon double bond here. The name will be 1-butene. So this will be the second isomer of butene. Now they are isomers. Why they are isomers? Because both of these are having same molecular formula, that is C4H8. See C4H8, again we are getting C4H8. So 1-butene is an isomer of 2-butene. Can you draw one more isomer of butene? I can just give you a hint. Just attach one methyl group in the middle carbon atom. Attach one methyl group in the middle carbon. Methyl group is this, CH3. This one is methyl group. In summary, a carbon atom is either hydrocarbons or organic compounds form only 4 covalent bonds, which means it is tetravalent. Carbon never forms 3 or 5 covalent bonds in its compounds. When 2 or more compounds have same molecular formula but different structural formula, they are called isomers of each other. The phenomena is known as isomerism. Thanks for watching. Press like, give comments, and share my video. For more videos, subscribe my channel and press the bell icon.